So, hi everyone. In this video, we are going to change the summation notation to the expanded na form. So, suppose we have this summation, the sum of I equals 0 to n, with this fraction, -1 raised to I over I plus 1. And we want to change this summation into its expanded na form. Okay, so we can then have this solution. So the sum of I equals 0 to n of -1 raised to I over I plus 1 is equivalent to this expanded na form. And how? So basically, we have to enumerate or to iterate through the values of 0 to n. And we are going to substitute that to this formula and substitute each of the values of I into this formula and add them up. Okay, and that is the concept of summation. So since the lower limit is 0, so we begin with this first term, -1 raised to 0 over 0 plus 1. Now the next term would be I equals 1. So substituting that in this formula, we have -1 raised to 1 over 1 plus 1. And if I is equal to 2, we have -1 raised to 2 over 2 plus 1, and so on until we reach n. Okay, so evaluating each of this, we have the first term will be equivalent to 1 over 1, because -1 raised to 0 is 1. And the second term will be equivalent to -1 over 2. The third term will be equivalent to 1/3. And the last term will be equivalent to -1 raised to n over n plus 1. Okay, so simplifying this further, so we have this expanded na form, 1 minus, so since this is negative, so we have 1 minus 1/2 plus 1/3 minus, since this is also negative, 1/4 until -1 raised to n over n plus 1. So what pattern can you see here? So we have this fraction increasing from 1/2 to 1/3 to 1/4. Okay, and also the sign between each term is oscillating between plus and minus. Okay, so we have this expanded form of this summation. Now, next is we want to change from the expanded form to the summation notation. So, babalik na rin naman siya natin. So, assuming we have this summation, we have this expanded na form, 1 over n plus 2 over n plus 1 plus 3 over n plus 2, and so forth until we reach n plus 1 over 2n. So what pattern can you see here? So in order for us to change from the expanded form into its summation notation, so the first thing that we have to do is observe the patterns. So we can see a pattern in the numerator and also a pattern in the denominator. Okay, so the first thing, so we can apply here the concept of the arithmetic and the geometric, right, and series. So first solution is to find the kth term of the series. So we can see that the numerators forms an arithmetic na sequence 1, 2, 3 until n minus 1, in which a is the first which is the first term. We can have a variable a which is equal to 1, and since this is an arithmetic na sequence, it means that there is a common difference between the terms of the sequence. Okay, and what would be the common difference? It is 1, because 2, the difference between 2 and its preceding value, 1 is 1. The difference between 3 and 2 will be 1, and so on. Now, using the formula of to find the kth term of a series, we have of an arithmetic series, we have a sub k equals a, which is the first term, plus k minus 1 times the common difference, which is d. And since the first term is equal to 1, so we have 1 plus k minus 1 times the difference, which is equal to 1. So this will be equivalent to 1 plus k minus 1, which is equal to k. So that means that the numerator of the formula will be k. Now, next is we are going to find the formula for the denominator. So the denominator forms also an arithmetic sequence. We have n plus 1, n plus 2, until 2n, in which the first term is equal to n, and the common difference between the sequence is also 1, because n minus 1 minus n, that will be equal to 1, n minus 2 minus n minus 1, so cancel out n, so 2 minus 1, that will also give us a 1, so n plus 3 minus n minus 2, that will also be equal to 1 because we cancel out n, and 3 minus 2 is equal to 1, and so on. So this is also the denominator is also composed of an arithmetic sequence with a common difference of 1. Okay, now since we know that it is an arithmetic sequence, so we can use the formula to find the kth term of the series of an arithmetic series. So a sub k equals a, which is the common difference. Not the common difference. The first term plus k minus 1 times the difference. Okay, and since the first term is n, so k minus 1 and the difference is 1. So this will be equivalent to n plus k minus 1 or k plus n minus 1. So we can then rewrite it into this. So we have the numerator, which is equal to k, which we have solved earlier, and the denominator is n minus 1 plus k. So then the summation will then be 1 over n plus 2 over n plus 1 plus 3 over n plus 2, which will be equivalent to this summation. The sum of k is equal to 1 to n plus 1. Since we started with 1, the lower limit is 1 to n plus 1, as you can see here, of k over n minus 1 plus k. So again, where did we get this value? So k is from where? K is the result of or the explicit na formula for the numerator, and n minus 1 plus k is the explicit formula for the denominator, which we have solved using the formula for getting the kth term of an arithmetic series. Okay, and if we want to shift the index of the summation, so if its index is 1 to n plus 1, so we want to shift it from 0 to n, so this will be equivalent to k plus 1 over n plus k, using the formula used to shift the index of the summation. Okay,